Welcome to meet the Nobel Laureate in Medicine or Physiology for 1997, Dr. Stanley Prusiner. The man who did as very few scientists do, but all of them get Nobel Prizes, I think. They really turned the concept we have upside down. And please tell me, Dr. Prusiner, what did you really turn upside down?
Well, I'm not sure I turned anything upside down. It was a discovery that people really didn't want to accept for a long time because it went against so many preconceived notions. The idea that a protein was infectious, that a disease could be both genetic and infectious, and then even spontaneous, these were concepts that people had a hard time accepting.
But why was it so controversial?
Well, I think that it was a long time in coming to understand that genes are made of DNA or RNA, primarily DNA, and that all infectious agents, the progeny of all infectious agents, are encoded by a strand of DNA or RNA, and in fact all organisms. So the idea that there should be something totally different and it should be alive, in quotes, it can replicate in a biological system, just I think was very difficult to accept. And I think people were justified in being skeptical because the discovery that DNA is the genetic material of life didn't occur until the middle of the 20th century.
So in a way you challenged the central dogma of molecular biology at that time, that all the information was contained in the DNA and the RNA, and the proteins were just the templates or the churning out of the. Now you proved that proteins in itself right, could contain information, so to say.
Well, yes and no. In the beginning, it seemed that way, that we were challenging the dogma. And as the story emerged, it became very clear that it fit within the dogma of biology, but that one had to make small revisions. And these revisions turn out to be groundbreaking in many other areas. The concept that a protein could then exist in two biologically active forms was not well accepted. And in fact, there were not good examples.
It took you 10 years to come to this conclusion, to really put forward the proofs for your idea. What kept you going? And everyone was suspicious about the ideas.
Yeah, this was a 25-year project.
Even more.
It took me about 10 years to really get into it and lay out what I thought were the real possibilities. And then another 10 years to gather the information that made it clear that these ideas were not science fiction, but in fact they were real, and that people who were skeptical were certainly justified, but that there now came a point where their skepticism no longer was really useful.
But what kept you going? I mean, 25 years is a long time.
Well, when you make a discovery like prions, you become very passionate about it. And you look for other things that are as interesting, where you might not find as much human opposition. And when you can't find something, if you're not very imaginative, you're not very bright, and you are unable to find another project that's as exciting, then you say to yourself, well, I'll just keep going on this. I have nothing better that I can work on.
But despite that, all the colleagues, or not all, but the scientific community around you really thought you were doing mad things.
Well, not everybody. There were enough people who were very supportive and who provided the day-to-day support, as well as being sufficiently convinced that we were doing good work to act as peers in the review of the work so that it was supported by the National Institutes of Health, because otherwise we would have never been able to survive. In addition, we had some private funding that was very important.
That is important.
Yes, the philanthropy was critical.
It's 7 years now since you came to Stockholm to get the prize.
Yes.
And I wonder what has happened since.
Well, my life has been a little more hectic.
Yeah.
In some ways, I've relaxed a little bit more. Although many people would not tell you that was true. And the work has continued to move forward.
Has there been any difficulties? And I mean, there were controversies even when you got the prize, and the protein-only hypothesis were challenged from many respects. And has you come up with some even more definite proof that is the protein-only theory that really holds?
Yes, this past summer we published 2 papers. One piece of work, we made a synthetic prion with a peptide that we synthesized in the chemical means. This was culminated in 4 years of work, where we published the first paper in the year 2000, so that was 3 years after the prize, and then a follow-up paper this past spring. Then in the summer we published another paper in which we made the protein in bacteria and isolated the protein and then refolded it and showed that we had made a synthetic prion that way. So we've done this 2 different ways, where we've started with a sequence that either produced in E. coli or produced by chemical means, and then changed the conformation of the protein and turned it into an infectious pathogen.
And you proved that this synthetic infectious prion managed to alter the shape of the proteins, the prions in the infected animal.
Well, if they didn't do it, then I don't know what did it.
But you were challenged on this as well afterwards.
Oh yes, even after we published these papers, we were challenged by people. Not a lot. Most people think that we have finished the task of convincing the world, but I think, there are a few. Okay. And that's normal. And that's they probably will never be convinced.
When you received your prize, you also gave a banquet speech, yes, where you said something like the Nobel Prize is hailing, or what's say in English? It's a celebration.
It's a celebration of science.
Celebration of science, yes, and culture.
And culture, well, in intellectual achievement in our civilization, and it's really, I think, unique. There is no other celebration like the Nobel Prize celebration.
It's interesting you mentioned science and culture together. We just got a new minister in Sweden in science and culture. The same minister and the same department, science and culture. And when he gave a press conference, just when he entered his chair, he didn't get a single question on science from the journalists, just about culture.
Well, I think that's not surprising. I think it's very difficult for people to ask questions about science just off the top of their heads. And I think one of the problems I had with the press for so long was that they were so uneducated about science. Now, to be fair to the press, they have very little time to write a story or to produce a story. And so being thrown into an area where some scientists are telling them the work is excellent and others are telling them that it's complete fraud and craziness, they don't know how to judge. I can well imagine when the Minister of Culture and Science is appointed and the press is asked to come to a press conference, if the press conference materials don't lay out in detail an agenda for science, so in an understandable lay language, then I can well understand they may not ask any questions.
But maybe you could also wonder what would, whose responsibility is this? If you want to be well known and if you want to communicate with the audience, I mean, you can't alter the journalist. The only thing you can alter is the scientist, maybe, yourself.
Wait, who are we talking about, the minister or myself?
Who is to blame if the communication doesn't work, the journalists or the scientists?
The scientists. I think that the scientists have to constantly try to translate what they do into language that most people can understand. And we are never going to be in a position where everyone is a knowledgeable layman, meaning they have a great scientific background, because whatever they learn in a university setting is already obsolete the day they graduate. So the best we can do is hope we can train them in some introductory science courses to give them a little background. But after that, it still is the responsibility of the scientists to try to communicate better with the public. And this is very, very hard to do, because each year science becomes more complicated. There's more and more specialized vocabulary. One of the things we don't have as scientists is we don't have a lot of people around who understand the details of the science intimately, who are interested in translating it for the public.
I mean, because the central idea when we talk about communication is that we talk about public understanding of science, but as you phrase it now, that is not very easy to do. So maybe you should turn the thing around. It's science understanding of public that is more interesting.
The scientists understanding the public, or the scientists making science more understandable for the public.
Yeah, but also to understand how the public thinks and feels and what their values are, to be able to phrase their science in a framework where people can understand it.
I think that's very legitimate. I'm not sure how practical that is in terms of making that happen.
Do you want to try?
Well, I can try. Whatever you'd like to talk about, I'll try to.
That anyway would be to make science as a part of culture.
I think that's wonderful, but the problem is, where do we start? How do we get this moving? And it's extremely difficult. I mean, you would hope that, for instance, the web would be a great place to do this. The internet is ideal in many respects. The problem with the internet is there's so much material on the internet. It's uncensored, it's unreviewed. So for the person who doesn't have a lot of knowledge, they now Google themselves into some website, and all of a sudden they're confronted with material that they can't judge whether this material is legitimate, whether it's reasonable, whether it fits with the scientific data, or it's some wacko person's ideas about a disease or some physical process. It's very, very hard for people to judge this. I'll give you an example in the field of mad cow disease. So you can go into the internet and look up mad cow disease, and you can find all kinds of material, much of which is unsupported by any scientific data. And there are a lot of people out there interested in this because this is a huge economic issue. It's a huge health issue. And yet there's an enormous amount of information which is available that comes from peer-reviewed scientific studies. And yet, if you don't have a reasonable working knowledge, you'll be confused when you get into this. So it's very, very hard, I think, to put science out there for the public. And we need to figure out how to do this. It's not a given. In fact, we do it very poorly.
But you're putting there's a big challenge to your colleagues and for the scientific community.
I think the challenge is huge. And I must say that I don't know how to do this. I find it very difficult to identify people who are very interested in doing this. In other words, someone who has a very good working knowledge of science, who can really judge, and we're not talking about all science now, we're saying, okay, someone who perhaps is very good in the field of neuroscience and neurologic diseases, and then finding such a person who wants to devote his or her life to making this available to the public.
Finally, what would your perspective be for the scientific community or for the society as a whole if you doesn't succeed in communicating science to the audience?
I think that there are huge problems for society if scientists can't communicate their science. It's so important. Number one, funding for scientific research depends upon public support. I think that policymakers, legislators, they need to be informed, and they need to be informed in terms that they can understand, not that we want them to understand. That's number one. Secondly, I think as our planet grows more crowded, people need the information in order to make decisions that benefit others on our planet. And third, if we don't communicate science, we won't see the science turned into technologic advantages for our civilization. So scientists have a huge responsibility. They're not very good at doing this. And at the same time, it's not fair to put all the burden on them because that's not what they want to do. That's not the job they've signed up for. They've signed up very often to roll back the frontiers of knowledge. So we need people in between, the people gathering the knowledge, the people consuming the knowledge. We need people in between to translate. And my guess is that we're going to need to create such a discipline for our society, which our society meaning civilization on this planet, which each year grows more and more dependent upon high technology.
So, to finish, let's hope that the audience is Googling around and Google to this interview and to share the ideas and the thoughts. Thank you very much for giving us your time.
Thank
Stanley
you.
Prusiner. Thank you.